Hi students, we will discuss regarding dual nature of radiation and matter. And this dual nature of radiation and matter, it shows that the behavior of a wave, it behaves as sometimes the electron behaves as a wave and sometimes it behaves as a particle. So it shows two different behaviors. So right in this lesson we will be discussing regarding electrons, free electrons. So first we will start with the electrons. Okay. So where do we find electrons? All of you must have heard regarding electrons. So in metals we have free electrons, right? So free electrons. In free electrons, these free electrons are available in metals, right? So metals, in the metals flow of electrons will be more. It means it has more electrons. So now free electrons. So coming here in metals, the electrons in outer shells of the atoms are loosely bound, right? In our chemistry we have seen that we have a nucleus inside the atom. That nucleus consists of protons and neutrons. Protons and neutrons collectively called as nucleus. And electrons will be always revolving in a circular orbit around the nucleus, right? So in metals we have electrons. They are loosely bounded for the atoms. They move about freely throughout the lattice of positive ions. See, positive ions are concentrated at the center so that the electrons are revolving around the nucleus. Such loosely bound electrons are called free electrons. So electrons which are revolving around the atom, they are called as free electrons. The free electrons, however, remain confined to the conductor and cannot leave its surface. Always these free electrons are bounded to the conductor and they can't leave the surface at ordinary temperature and under moderate electric field. See, these free electrons have a chance to leave the surface or to escape from the surface, but at ordinary temperature and moderate electric field they can't leave the surface of the conductor, right? Now the movement of electrons comes out of a metal surface with its negative charge. See, electrons normally have a negative charge. The metal surface acquires an equal positive charge. Suppose the free electrons wants to come out from the metal surface, then the positive charge which is always already present in the nucleus will get the positive charge and it applies equal force on the electron and it instantly takes back the electron to stay in the atom itself and pulls back. There is some potential barrier at the metal surface. See, if free electron wants to escape from the metal surface, this equally the positive charge gains the energy and it's pull back the electrons to stay in the surface of the metal. But that is called as a potential barrier. Okay. The positive charge gains the equal energy and it pulls back the electron to stay in the atom. That is called as the potential barrier. Now what happens, which the free electrons have to overcome in order to just escape from metal surface. If the electron wants to escape from the metal surface, it has to gain some more extra energy for this process. So here the minimum amount of energy required by an electron to just escape from the metal surface, this is generally denoted by W naught or phi naught measured in electron volt. So electron requires some energy to escape from the metal surface or to escape from the potential barrier. See, if it gets more energy than the required energy, then it can go out or it can escape from the metal surface. That is called as the work function, that is denoted with the letter of W naught or phi naught. Okay, this work function or energy is measured in terms of electron volt. Okay, so what is the definition of electron volt? Electron volt, 1 electron volt is the kinetic energy gained by an electron when it is accelerated through a potential difference of 1 volt. So here, when an 1 electron volt is kinetic energy gained by an electron. It is the kinetic energy gained by the electron when it is accelerated through a potential difference of 1 volt. This is the definition of electron volt. 1 electron volt is equal to 1.602 into 10 to the power of minus 19 coulomb into 1 volt potential difference. So it comes out to be 1 eV, 1 electron volt is equal to 1.602 into 10 to the power of minus 19 joule. See, whenever the free electrons are there, if they want to escape from the surface barrier or potential barrier, they must gain some more extra energy. So that energy, minimum amount of energy required by the electron to just escape from the metal surface is called as the work function. Okay, 1 electron volt is defined as the kinetic energy gained by an electron when it is accelerated through a potential difference of 1 volt. Here 1 electron volt is equal to 1.602 into 10 raised to minus 19 joule. So here very important thing is electron volt is unit of energy in atomic physics, atomic and nuclear physics. Energy we will measure here in terms of electron volt, especially in atomic and nuclear physics. See, as you know, here we have some more metals here like cesium, potassium, sodium, calcium, molybdenum, plumbum, aluminium, mercury, copper, okay, silver, okay, and platinum also. Here, if you go for this table, we have work function for some photosensitive metals. So cesium, it is having 2.14, potassium 2.30, sodium 2.75, calcium 3.20, molybdenum 4.17 electron volt, plumbum 4.25 electron volt, aluminium 4.28 electron volt, mercury 4.49 electron volt, copper 4.65 electron volt, Ag 4.70 electron volt, Ni nickel 5.15 electron volt, platinum 5.65 electron volt. If you observe this table, see for the cesium atom, from the cesium atom if you want to remove an free electron, we require 2.14 electron volt. It means that if you provide 2.14 electron for the metal surface, then cesium atom, from the cesium atom electrons will be coming out. And if you provide less than electron volt, like 2.14 electron volt, the energy is not sufficient for the electron, so that the process will not take place. And similarly for potassium, from the potassium if you want to remove an free electron, we require 2.30 electron volt. If you provide less than this value, the process doesn't take place. Similarly for all these metals, from this table it is clear that Cesium atom is having lower work function value, that is 2.14 electron volt, and platinum is having 5.65 electron volt, which is higher value, which is having higher value from this means platinum. From platinum, if we want to remove an electron, we need to provide 5.65 electron volt, whereas for the cesium atom we require 2.14 electron volt, right? So coming here, electron emission. Just now we discussed electron. So from our lower classes we studied and we know that electrons discovered by J.J. Thomson, and those electrons always revolving in an atom, and inside the atom we have a proton and nucleus, and in the nucleus we have proton and neutron. Okay, and this protons having positive charge, our electrons have the negative charge. They will be always revolving around the nucleus, and it is not easy to get the electron from a certain element. Okay, so for that some energy is required. So minimum energy required for the electron to escape from the metal surface is called as the work function, that is denoted with W naught or phi naught. And in atomic physics and nuclear physics we will use the unit for energy as electron volt. 1 electron volt is equal to 1.607 into 10 to the power of minus 19 electron volt. Minus 19 joule. 1 electron volt is equal to 1.602 into 10 to the power of minus 19 joule, right? From this table we know that cesium is having lowest work function 2.14 electron volt, and platinum is having 5.65 electron volt, which is maximum for the platinum and which is lower for the 2.14 electron volt for the cesium. Now we have a processes. So loosely bounded electron can be escaped from the metal surface, but we have a few types, and those 4 types we will discuss one by one. Coming for emission, first we must know what is the meaning of electron emission, right? So the phenomenon of emission of electrons from a metal surface is called electron emission. For the emission of electrons from the metal surface, the energy of electrons must be higher than the work function. For their release from the metal surface, the electron may be supplied the required amount of energy by any one of the methods. See here, for the electron emission, the process of emission of electron from a metal surface is called electron emission. So the process of getting electron from the metal surface is called as the electron emission. Suppose if the energy, suppose for the cesium atom we require 2.14 electron volt. Okay, for example we have taken for the electron emission process cesium atom, cesium metal. So here if you provide 2.14 electron volt, then the phenomenon of electron emission process is possible. If you provide 2 electron volt which is lesser than 2.14 electron volt, in this case the electron emission process will not take place at all, because the minimum energy required for this cesium atom is 2.14 electron. If you provide 2 electron volt lesser than this value, the reaction doesn't take place, the emission does not take place. So for the release of the electron from the metal surface, the electron may be supplied the required amount of energy by any one of the methods. It must be supplied required amount of energy, then only the process can take place. If you provide less than 2.14 electron volt for the cesium metal, the reaction doesn't take place. I mean the emission doesn't take place, isn't it? So I hope you understood this, the statement. Okay. We have emission process. We have four types. One is thermionic emission. Second one is field emission or cold cathode emission. And the third one is photoelectric emission. And we have secondary emission. These four methods. The escape of an electron or the process of emission of an electron can be done with the help of these four processes, namely thermionic emission, field emission or cold cathode emission, photoelectric emission and secondary emission. So one by one we will discuss what is this thermionic emission, field emission, photoelectric emission and secondary emission. Right. So coming to thermionic emission, thermo means heat. By the process of heat. So here when a metal is heated, its free electrons get sufficient thermal energy and they can overcome surface barrier. See here, whenever the metal is heated, the free electron gets the sufficient thermal energy, okay, and they will overcome from the surface barrier. This phenomenon is called thermionic emission and the emitted electrons are called thermions or thermoelectrons. See, thermionic emission means by the process of heat. Whenever a metal is there, if we provide sufficient thermal energy and the electron gains the energy by thermal process and it escapes from the surface barrier. This method is called as thermionic emission. Okay, and the emitted electron is called as the thermoelectron. This is thermionic emission. Then coming to second emission, second process, that is field emission or cold cathode emission. What is the meaning of field emission? See, when a metal surface is subjected to very high electric field, it means by the supply of electric field. So for a metal we will supply sufficient electric field. We apply sufficient high electric field for the metal surface of the order of 10 to the power of 3 to 10 to the power of 8 volt per meter. If you place the metal in high electric field of the order of 10 to the power of 3 to 10 to the power of 8 volt per meter, electrons are emitted from it. So then what happens? By the presence of this heat energy from the electric supply, the electrons gets emitted from it. This is known as field emission or cold cathode emission. This method is dangerous and less efficient. See, by applying electric field also we can do this emission process by subjected to very high electric field of the order of 10 to the power of 3 to 10 to the power of 8 volt meter. Electrons are emitted from it. This is known as field emission or cold cathode emission. Okay, this is very dangerous because we are applying electric field for the emission of an electron for the metal surface, right? Now coming to third one, that is photoelectric emission. See, in this process in which electrons are emitted from the metal surface, when electromagnetic radiations of sufficiently high frequency are incident on it, the emitted electrons are called photoelectrons, but their rate of emission very low. See here, photoelectric emission means this is the process in which electrons are emitted from a metal surface when electromagnetic radiations of sufficiently high frequency are incident on it. Suppose light, in the presence of UV light, the light energy is falling on the surface of a metal surface. The electrons gains the energy, and if they get sufficient energy, they will come out from the surface barrier. So this is called as photoelectric emission. The emitted electrons are called photoelectrons, but their rate of emission is very low. This process is very low process, means it is a slow process. Okay, coming to next one, that is secondary emission. When fast moving electrons strike a metal surface, they transfer some of their energy to the free electrons of the metal. As a result, the energy of the free electrons becomes more than the work function of the metal and they get ejected from the metal surface. The emitted electrons are called secondary electrons and this method is called secondary emission. See, whenever already electrons are present in a metal surface and we are sending one more electron which is having higher energy, so that fast moving electron comes and collide with the electron which is free in state. So this energy is completely transferred to the free electron and this free electron gains the energy from the fast moving electron and it escapes from the surface barrier. So this is called as the secondary emission process. Okay. These are the four types we have in a emission process. One is thermionic, by the presence of heat. Field emission, by applying electric field for the metal surface. Photoelectric emission, by the presence of UV light. Secondary emission, when a fast moving electron comes and collides with the free electron and it transfers all the energy to the free electron and free electron gets the energy from the fast moving electron and it escapes from the surface barrier. This process is called as secondary emission. This is all about emission process, types of emission process. Okay, in detail we have photoelectric emission for your syllabus. So we must discuss photoelectric emission in detail. So now photoelectric effect. Photoelectric emission is also called as photoelectric effect. Okay, photoelectric effect, when light of suitable frequency illuminate a metal surface, electrons are emitted from the metal surface. This phenomenon is called photoelectric effect. Whenever light energy falls on a metal plate, the metal surface gains the energy, means on the metal surface we have free electrons. So those free electrons gains the energy and they are emitted from the metal surface. If the sufficient energy is given, then the electrons gains the energy and they will escape from the metal surface. This phenomenon is called photoelectric effect. So this is all about photoelectric effect. Next we will discuss in detail of photoelectric effect, how this photoelectric effect came into existence. First, which scientist has worked on it and what are the phenomena and what are the properties, how this process takes place. These all things we will discuss in the next class. This is Aruna. This is your favorite channel svpc Aruna Uppar. So please subscribe to this channel and share to your friends also. Thank you.